It's math time with Heinz. It's math time with Heinz. Math time.
Hello, Algebra 2. Welcome to your Unit 1 practice test solution. So let's jump right in. So P of x equals x to the third minus 3x squared minus 2x plus 4. Which statement is true? So if I look at all these statements here, all of them start with something is a factor. Well, huge idea. What makes something a factor? A remainder of 0. If I divide it by that factor, I should get a remainder of 0. So from the start of this, I can see that this is a remainder theorem question. This is a clearly this question's not going to be on your test, but the remainder theorem is. So how do I check if x minus 1 is a factor? Well, I plug in the opposite. I plug in x equals 1. So I'm not even going to deal with this choice here. Here I plug in x equals negative 1. Here I plug in x equals negative 1, so no. So I'm already down to choices 1 or 4. So what makes me a factor? Well, the output, when I plug in the opposite number, the output is the remainder. So that's why it's choice 4. Because the remainder I don't want to be 2. This would tell me the remainder is 2. I want a remainder of 0 to be a factor. When factored completely, this trinomial is equivalent to, so we've got to factor this trinomial completely. M to the fifth plus m to the third minus 6m. So I'm going to factor out an m. And I'm left with m to the fourth plus m squared minus 6. Well, this is still a trinomial, and it's an easy trinomial. I don't need to split the middleman. I don't need to split the middleman because it's 1 in front of that there. Well, how do I factor trinomials? What multiplies to negative 6 that adds to my middleman of 1? It'll be positive 3 and negative 2. And remember, don't lose your GCFs. We spent a lot of time talking about factoring strategies. Make sure you know how to do all of them. Notice that this is not the difference of perfect squares, and we can't factor the sum of squares. So we can't even touch that because of the plus, and then the minus sign there, I'm just going to leave as a minus 2 because 2 is not a perfect square. You have to know how to factor. There's going to be some kind of factoring questions on your test tomorrow. Which expression is equivalent to this? So I need to use division here. I'm going to use reverse tabular, but also know that you can long divide. So I got 2x to the fourth, 8x to the third. I'm watching out for placeholders. You have to make sure that you have every term along the way, and I do. I believe that's a 14. I don't know why it didn't copy over. That's okay. So we push the first term in and we say, self, what times x is 2x to the fourth? Well, 2x cubed. 2x cubed times 6 is 12x cubed. But I need 8. What in 12 gives me 8? Well, I need negative 4 of them. So negative 4x squared times 6 is negative 24x squared, right? Multiply. I need another negative 1 to get to negative 25. And this is where this problem gets weird, because you have negative 6 and you need negative 6, so I'm just going to put a 0 there. Sometimes that happens where you just put a 0, so the whole column zeroes out at that point. Well, I happen to be at my remainder. I'm at 0. That box plus my remainder has to give me 14. So guess what my remainder equals? 14. And we write our answers in the form of quotient plus remainder over divisor. Quotient plus remainder over divisor. So I get choice 3. A quick way you could have done this question is plug x equals negative 6 into the numerator. I could have used the remainder theorem to quickly find the remainder. Which description could represent the graph of 4x squared parentheses x plus a minus x minus a? So there's a couple ways to do this. If a is an integer, you could plug your favorite number in for a and use your graphing calculator. You could say, I don't know, let a equal 3 and plug it in and see what you get. Or you could have distributed this back here and said, all right, it's an x to the third polynomial, and I know my n behavior dance moves. I have an odd degree and a positive leading coefficient, so my right hand goes up and my left hand goes down. Well, if I have a third degree polynomial, there's no way I touch the x-axis 4 times. I only have 3 zeros, which if you finish grouping this, because I kind of started grouping it for you, if you finish grouping this, you should be able to realize your factors are x plus a, and then 4x squared minus 1, but that's the difference of squares there. 2x plus 1, 2x minus 1. You'll notice you'll have 3 x-intercepts. You'll have 3 x-intercepts of negative a, negative 1/2, and positive 1/2. Those are all your zeros. But I only have 3 of them because it's a third degree polynomial. So now I just need to look at the end behavior. As x gets negative, so this is my left hand. As x gets negative, are my y values going up? No. As x gets negative, my y values are going down. As x gets positive, my y values are going up. It's choice 2 there. Okay, so this question was talking about zeros and end behavior. Those are 2 important ideas that we need when we graph polynomials. So more factoring. Who doesn't love factoring? And I like this one because we get to go over all the techniques. So this first one, 4k squared minus 49. Hopefully you realize this is the difference of perfect squares. 2k is in the front seat, plus 7 and minus 7's in the back seat. That looks good to go. So that's true. I want what's incorrect. Perfect cubes, everyone's favorite. So perfect cubes, I need to come up with the linear factor. I need to come up with my linear factor here. So a, and then 2b, and it's the same sign. And then there was that pattern that I've been saying since, I don't know, the middle of September. Square the first, multiply them, square the last. Same, opposite, always positive. Perfect cubes, watch that homework video if you need more practice, but this checks out here as good. I've got 4 terms here, so this must be grouping m to the third plus 3m squared minus 4m plus 12. This must be grouping here, so let's group. I can take out, I just deleted, oh no, I just deleted my blue pen. It's okay. Let's take out m squared, so m plus 3, which means I need m plus 3 over here. Well, what times m? I would need a negative 4 here, but wait. Negative 4 and 3 doesn't give me positive 12. So I can't factor this here. This problem cannot be factored because you can't group it like that. It looks like it's a grouping problem, but you can't. And then finally, I have 6 terms here, and I'm going to give you guys who are watching the video the hint right now that there will be a 6-term factoring problem on your test, where either you make groups of 2 or you're going to make groups of 3. So it's the same grouping process. You just have to decide, do I do groups of 2 or I do groups of 3? But number 3 is the incorrect factorization there. If A, B, C are real numbers, well, guess what? You can plug numbers in then and look at your calculator. What could be the graph of negative a, x plus b, and then I have x minus c squared, so I have 2 of those. So my zeros are at x equals negative b and x equals positive c. So negative b and positive c are my zeros. And then the only difference between these 2 graphs here is the end behavior. Well, I have 3 factors, so it's an odd degree with a negative number out front. I have negative a. So my end behavior looks like this. And notice, why do I turn around at C? When I hit C, I turn around because it's a repeated 0. That's a huge idea that I am going to ask you to explore on your test is if I have that repeated 0, I've got to turn around when I hit the x-axis. So this question looks really crazy, but all it was asking you about was zeros and end behavior again. Determine and state the value of k such that x minus 1 is a factor. Well, if something is a factor, that means x equals 1 is a 0, or I have a remainder of 0 when I divide by that. So if x equals 1 is a 0, let's plug that in. Wherever I see a 1, I'm plugging that in. And it should equal 0. If this is a factor, when I plug in a positive 1, I should get 0. 1 minus k plus 2 equals 0. 3 minus k is 0. Just got to solve this now, so k equals 3. Done. This is the polynomial that I was talking about. That's the polynomial I want. X to the third minus k, x squared plus 2x. So if I tell you something's a factor, you either plug in a 0, you either plug in the opposite and set it equal to 0, or divide. Given r of x here, find r of 2. So this is literally a 9th grade question. How do I find r of 2? I plug in a 2. 2 to the third minus 4 times 2 squared plus 4 times 2 minus 6. And then you literally type that whole thing into your calculator, and you get an answer of, I'm just doing it in my head right now, you get -6. Don't solve for r. This is function notation. When x is 2, y is -6. Well, what does my answer tell me about x minus 2? So again, if I want to know about x minus 2, notice I plug in a positive 2. This tells me x minus 2 is not a factor, since the remainder will be -6. The remainder will be -6. That's what the remainder theorem tells us, will be -6, not 0, if we were to divide. I'm not even going to divide because I know the remainder is -6. So it's not a factor because the remainder theorem tells us it's not equal to 0. Algebraically, find me the zeros. Well, I'm going to set this polynomial equal to 0. Or I could just look at my graphing calculator and find them, right? If I want to know the zeros, I could throw that in my calculator. So if this was a multiple choice question, I could throw that in my calculator and I'm good to go. So it's grouping. This is a grouping question. X plus 1. I better get x plus 1 over here. If I take out a -4, I will. So I un-GCF, I take out that common factor. Notice there's only one of them. It's not squared. And then I've got some difference of perfect squares popping up. So my zeros are -1, -2, and +2. Those are my zeros because I got my factors. And again, you could look at your graphing calculator and go to your table, or you could see where does this polynomial hit the x-axis. It hits it 3 times at -1, I messed that up, -2, and +2. So again, you should know how to do this algebraically, but you should also know how to do it on your calculator. Determine the quotient and remainder. So it's a division question. I'm dividing by 3a minus 2. Sorry for my long dividers. I'm doing reverse tabular. I've got 6a to the third, 11a squared. Gotta watch out for those placeholders, but we're all good here. All right, here we go. I got 6a to the third. What times 3a is 6a to the third? Well, 2a squared. Multiply. I'm at -4. How do I get to 11? I'm at -4. How do I get to 11? Well, that's 15. 15 minus 4 is 11. So 5 times 3 is 15. I'm at -10. How do I get to 4? I need to add 6. 2 times 3 is 6. 2 times 2 is -4. So it's not a factor. 3a minus 2 is not a factor because I have a remainder. I have a remainder of what? -4 plus my remainder has to give me -6. If I add 4 over, I get r equals -5. So I have to make sure I write the answer in the correct way. The answer is 2a squared plus 5a plus 2 plus I have that fractional piece that didn't divide out, -5 over 3a minus 2. Quotient plus remainder over divisor. Make sure you're writing your answers in that correct form. 2 more. This polynomial has a leading coefficient of 1. Write me its equation in standard form. So if I want to know the equation of this polynomial here, I need its zeros. The zeros are at 3, 0, and -4. So if those are my zeros, -4, 0, and 3, I need my factors. So my factors are x plus 4, x minus 3, and then everyone always panics with the 0. Well, you could put x minus 0, or you could just put a plain old x. So you could write x minus 0, or it's just a plain old x that I normally put out front. But wait, there's more, said Billy Mays. I've got a repeated 0 here because it touches it and turns around, so I actually have 2 of those. So that's factored form. How do I get to standard form? Well, I've got to multiply them. I've got to clean this up here. Normally I'm done, but that's factored form. Standard form looks like this, which isn't too bad because now I just need to distribute. So x to the 4th plus x to the 3rd minus 12x squared. That's my equation for f of x. If I ask you for an equation, make sure it actually has an equal sign. Y equals f of x equals. So the key thing is here, if I know my zeros, I can work backwards and get my factors. Make sure you know how to handle those double zeros. And finally, number 12. If this is g of x and x plus 1 is a factor, find me the other factors. So if I tell you something's a factor, you can divide by it. So I'm going to divide by x plus 1. So 2x to the 3rd minus 3x squared minus 17x minus 12. So 2x to the 3rd goes there, and we divide. Hopefully you're really good at division right now. Negative 5 and 2 makes negative 3. I need negative 12. And notice I have a remainder of 0 because I told you it was a factor. So that means g of x, how can I factor it? X plus 1 is one of the factors, and we just found out the other factor was 2x squared minus 5x minus 12. So now I need 3 linear factors, which means I've got to factor this guy some more. So it's a trinomial, and I factor trinomials by asking myself, what multiplies to negative 24? That adds to negative 5. What multiplies to negative 24 that adds to negative 5? Well, I think negative 8 and positive 3. So I'm going to split the middle term there and then group. So I group the terms. X minus 4, I need an x minus 4 here, plus 3. X minus 4 times 2x plus 3. And then finally, x plus 1, g of x equals. I don't want the zeros. I want to know what are my 3 factors. If I could easily get the zeros, but I didn't ask you for that. I asked you for the factors. If I ask you for factors, stop here. If I ask you for zeros, make sure you get me those zeros. So hopefully you realize you need to know how to divide, how to factor all the different strategies. You need to know how to graph, which means zeros and end behavior, and you need to know the remainder theorem. It's kind of all we did in this unit was division, factoring, graphing, and the remainder theorem. So that's all I've got for you. Best of luck studying, folks.